Here we are going to discuss about the position of a point which lies inside of a triangle. Okay, so we know that whenever a straight line is given to us, let us say the equation of this straight line is ax plus by plus c is equals to 0. And suppose 2 points are given to us, they are x1 comma y1 and x2 comma y2, and they lie on the same side of the straight line. Then we say that the value of the expression ax1 plus by1 plus c and ax2 plus by2 plus c, they will have same sign. They will have same sign. That is, the ratio of these two values, will be always greater than 0. Okay, when the 2 points are lying on the same side of a straight line. Now, if these 2 points lie on the opposite side of the straight line, suppose here it is x1 comma y1 and say here x2 comma y2, then what we say? We say that ax1 plus by1 plus c and ax2 plus by2 plus c, these two will have opposite sign, right? That is, the ratio of these two values, will be always less than 0. Is this clear? This we all know. Now we will use this conception to find out the thing what is called the position of a point which lies inside of a triangle. We will find out the condition to find out the value of the variable maybe which is given in the question. So now directly move for the theory part. Now I will discuss the actual way of finding out when the point is inside of a triangle. Let us say x dash y dash, this is the point which is lying inside of a triangle whose three sides are given as a1x plus b1y plus c1 equals to 0. The side CA is a2x plus b2y plus c2 equals to 0, and the side AB is a3x plus b3y plus c3 equals to 0. So the triangle, if I draw, it will look something like this. I have given you the three sides and as well as its respective equations. Is it okay? Now the point P x dash y dash which is lying inside the triangle. Now we have to find out the condition. Now for that, first of all we have to do is we have to find out the vertices of this triangle. To get the vertices, say A, we have to solve AB and AC, because we know when we solve simultaneously these two linear equations, we always get the point of intersection. So when we solve AB and AC, we are going to get A. When we are solving AB and BC, we are going to get B. And when we are solving BC and AC, we are going to get C. Let us assume, for the simplicity of the problem, that if I solve AB and AC, we are going to get the coordinates of A as x1, y1. I'm sorry. Yeah, it's x1, y1. And the coordinates of B is x2, y2, and the coordinates of C is x3, y3. Okay. Now let us just consider a case. You see, with respect to the line BC, that is a1x plus b1y plus c1 equals to 0, the points A, that is x1, y1, and the point P, which is x dash y dash, which is lying on the same side of this straight line. So therefore we can say that a1 x dash plus b1 y dash plus c1 divided by a1 x1 plus b1 y1 plus c1 is greater than 0. Is this clear to all of you? Just now I told you, because this thing you have already learned. Okay. Now similarly we can say that the points x2, y2 and x dash y dash, they are lying on the same side of a2x plus b2y plus c2 equals to 0. So we can say a2x dash plus b2y dash plus c2 divided by a2x2 plus b2y2 plus c2, that is greater than 0. Similarly we can say that the points x3, y3 and x dash y dash, which is lying on the same side of a3x plus b3y plus c3 equals to 0. Hence this condition. Is this clear to all of you? So these are the three conditions that we will get when the point P is lying inside the triangle. Okay, so now all we have to do is we have to find out the common region in this part to get the required values of x dash y dash, or sometimes conditions they used to say. So to find out the condition, or it may so happen we have to find out the variables which is given to us as a point P to find out its range or find out its value or whatever it is. Are you getting my point? But these are the three cases which we have to consider simultaneously to get the common region for finding out that condition. Okay, so now let us move directly for a problem. See this one. For what values of the parameter t does the point P t comma t plus 1, means this is the coordinate of that point which is lying inside the triangle ABC, where the three vertices are given to us. In the theory part that I have discussed, I have given you the equation of the straight lines. Here they have given you the coordinates of the points, that is the vertices of that triangle. So here all we have to do is we have to first find out the equation of the sides AB, BC and AC, then we will proceed. So let us draw the triangle ABC. The vertices are 0, 3, minus 2, 0 and 6, 1. So let us just first find out the equation of AB. The equation of AB is the intercept form I am using. So we are getting the equation of AB as okay. Now let us find out the equation of BC. We are using 2-point formula. Y minus y1 by y2 minus y1 equals to x minus x1 by x2 minus x1. Okay, so we are getting basically this is the equation of the side BC, and the equation of side AC is, again we are applying the 2-point formula, y minus y1 by y2 minus y1 equals to x minus x1 by x2 minus x1. So we are getting something like this. It will be 3 times y minus 3 is equals to minus x, isn't it? So the equation becomes x plus 3y is equals to 9. So these are the equations of the sides AB, BC and AC respectively. Now the point P, which is t comma t plus 1, this point is lying inside the triangle. So we can say that the point P and A are on the same side of the straight line BC. The points P and A are on the same side of BC. Now the equation of BC is x minus 8y plus 2 equals to 0. So therefore we can write t minus 8 times t plus 1 plus 2 divided by it will be 0 minus 24 plus 2. That should be greater than 0 because these 2 points are lying on the same side of the straight line BC. So we are going to get t minus 8t minus 8 plus 2 is less than 0. Why? Because the denominator here is negative. So the sign will get changed. So we are getting from here as minus 70 minus 6 is less than 0, which implies t is more than 6 by minus 6 by 7. So this is the first condition that we got, that t is greater than minus 6 by 7. Now again, the point P and B are lying on the same side of the straight line AC. The equation of AC is x plus 3y minus 9 is 0. Since these 2 points are lying on the same side of AC, hence divided by AC means we are getting, so the point B is minus 2, it's minus 2 plus 0 minus 9, which is greater than 0 again. So we are going to get as, again the denominator is coming to negative, so t plus 3t plus 3 minus 9 is less than 0. Sign will get changed. So we are going to get as 4t is less than 6. That implies t is less than 3 by 2, right? This is the second condition that we got. Now the last one is the point P and C. Point P and C, they are lying on the same side of AB. Therefore, the equation of AB is, what we got is 3x minus 2y plus 6 equals to 0. So we will write it as 3t minus 2 t plus 1 plus 6 divided by the point C is 6 comma 1, so it's 3 into 6, that is 18 minus 2 plus 6 is greater than 0. Now you observe that the denominator is positive, so there is no need to change the sign. So we are getting 3t minus 2t minus 2 plus 6 is greater than 0. So we are going to get it as t plus 4 is greater than 0, which implies t is greater than minus 4. And this is the third condition that we got. So all we have to do is we have to combine these three. We have to combine these three to get the common region to find out the range of t. So as we can see that t is more than minus 4, here t is more than minus 6 by 7 and t is less than 2. If you combine these three, we are going to get that t is more than minus 6 by 7 and it is less than 3 by 2. That will be your final answer. Is this conception clear? So this is one way of solving this sum, but now I will show you a different method of solving this sum, and you can do it in much easier and in very short span of time. Okay, now let us move for the shortcut method. The point which is given here is t plus 1. This is the parameter where t is the parameter. So this point is lying on the curve. This point is lying on the curve. We can combine these two and we can write that y equals to x plus 1. That is, y is equals to x plus 1 is the equation of that straight line on which this point t and t plus 1 is lying. It can be any point on this line. Okay. Now let us plot this coordinate A, B and C in the plane we get. Let us come to this. Let us draw this coordinate axis and we are plotting those 3 points A, B and C, and let me join by the straight lines. We are going to get the triangle ABC. Okay. Now you see y is equals to x plus 1. This is basically a straight line. which is intersecting the y-axis at the point 0, 1. So let me draw a straight line. The point 0, 1 is there, and this is the straight line, right? On this straight line, we have the any point on this straight line is t and t plus 1, but they have said that this point is lying inside the triangle. Okay, so that point can be any point within this region. Okay, within this straight line, on this straight line inside the triangle, the point can be anywhere. Okay, now we see that this straight line is intersecting the straight line, the sides BC and AC at 2 points, and the 2 points, let us say, be D and E. Now we are trying to find out the abscissa of the point D and the abscissa of the point E. To get the abscissa D, we have to solve the equation BC and DE. Okay, we have to solve the equation BC and AD. For that, we know that the equation of BC is 8y is equals to x plus 2. Now if we solve this equation and y equals to x plus 1, we will get the coordinates of this point D. So we are only interested of finding out the abscissa. So in place of y, I am writing x plus 1. I'm just solving these two equations. So we are going to get 7x equals to minus 6. So that implies x is minus 6 by 7. Is this clear? So this is the abscissa of the point D. Now to find out the abscissa of the point E, we have to solve the equation AC and y is equals to x plus 1. Now the equation of AC is x plus 3y is equals to 9. This we have already found. So in place of y, I am writing x plus 1. So we are getting 6. So x is nothing but 3 by 2, right? So x is equals to 3 by 2. This is the abscissa of the point E, and the abscissa of the point D is minus 6 by 7. Is it clear? Now let us draw perpendiculars from D and E on the x-axis. Okay. Now you see the point T and T plus 1, it is any point on this segment, right? On this straight line which is inside the triangle. Now any point on this straight line is T comma T plus 1. So where T is basically the abscissa of that point. Now it is clear from the diagram that your abscissa T will always lie between the abscissa of the point D and D. So directly from here we can write that your T is lying between minus 6 by 7, because it is more than this abscissa, and less than this point, which is 3 by 2. Therefore, my required answer that we got in the previous also by that previous method is lying between minus 6 by 7 and 3 by 2. That will be your final answer. Now, one thing for this kind of problems, whenever we draw the figure in that plane, it is easier to find out the range of t or whatever variable is given to us if we can draw the line or the curve, that variable curve which is given, variable point which is given to us in the parametric form. But until and unless we can't draw that graph, we cannot find out this. Here one question can come, why I found the abscissa, why not the ordinate? Even if you find out the ordinate, you will get the same answer, because you see again your ordinate t plus 1 will be what? It will be more than the ordinate of that point D as well as the ordinate of the point E. So it will be more than that, and it will be less than the ordinate of the point D. So from here also, if you solve, you will get that t is lying between minus 6 by 7 and 3 by 2. Is this clear? Now let us take another example. Determine all values of alpha for which the points alpha comma alpha square lies inside the triangle formed by the lines 2x plus 3y equals to 1, x plus 2y equals to 3, and 5x minus 6y is equals to 1. Okay. Now, it can be seen very easily from the problem that the point alpha comma alpha square is moving on the curve y is equals to x square for any value of alpha, right? So y is equals to x square is the curve on which this alpha and alpha square is moving. Now we have to find out that part which is inside the triangle formed by these three lines. Now let us take the three sides of the triangle B. Let AB is 2x plus 3y is equals to 1. BC is x plus 2y equals to 3, and CA is 5x minus 6y is equals to 1. Now to get the coordinates of the vertices A, B and C, we will solve these straight lines by taking in pair. So we will get the coordinates of A will be, solve I am not doing because I have already done it. You can solve this equations taking in pairs simultaneously. So you will get the coordinates of A is 1 by 3 comma 1 by 9. The coordinates of B will be minus 7 comma 5, and the coordinates of C will be 5 by 4 and 7 by 8. Is this clear? So these are the vertices of the triangle. Now if we plot those points A, B, C in the plane, so we are going to get the curve something like this. Suppose this point will be your minus 7 comma 5, which is your point B. Then the next point will be this point, which is your A. The point is 1/3 1 by 9. This point is your A. And the another point is C, which is say 5 by 4 comma 7 by 8. Okay. Now if we just draw the triangle, we are going to get something like this. Let me just change the color of the ink. So the triangle will look something like this, isn't it? Not exactly like this, but almost. It's okay. It is understandable. Now we have to draw the curve y is equals to x square. Okay, it's a parabola. Now first of all we have to think where this parabola is intersecting these straight lines, I mean the sides of the triangle, that is where it is intersecting the side AB, BC as well as CA. So now let us first solve y is equals to x square and the side AB. That is, we want to find out the points where this parabola is intersecting the side AB. So in that case, what we get, the equation of AB is, I'm just solving, just check it out. Right? So we are going to get okay. So now if we go for, let me just check it whether I'm correct or not. Yeah. So we are getting the points x as 1/3 or it's minus 1. When x is 1/3, your y is 1 by 9. And when x is minus 1, your y is 1. So the point of intersection of that parabola with the side AB is at 1 by 3 comma 1 by 9 and minus 1 comma 1. Now you see 1 by 3 comma 1 by 9 is very much the point A, isn't it? The very much the point A means it is, I mean, the parabola is passing through the vertex of the triangle ABC, okay, at the point through the point A, okay, and the another point is minus 1 comma 1, okay. This is for the parabola and the side AB. Now let us solve. Y is equals to x square and the side BC. So just check it. I am just solving it to get the point of intersection with the side BC. So we are going to get something like this. It will be x minus 1 into 2x plus 3. Am I correct? Just let me just check it. 2x square minus 2x plus 3x. Yeah. Okay. So we are getting x is equals to 1 or x equals to minus 3 by 2. So if x is 1, we are getting y as 1, and if x is minus 3 by 2, we are getting y as 9 by 4, right? Therefore, the points where the parabola is touching the sides BC is at the point 1 comma 1 as well as the point minus 3 by 2 comma 9 by 4. Is this clear? Now next one is the parabola y is equals to x square and the side AC. So again I'm solving, please check it. So we are getting plus 1 is 0. So we are basically getting in this case as it's 3x minus 1 and 2x minus 1. So that gives you 0, implies x is 1/3 or it's half. When x is 1/3, then y is your 1 by 9 and this is 1 by 4. So the point is, the point where the curve y equals to x square is intersecting the straight line AC is at 1 by 3, 1 by 9 and half comma 1 by 4, right? Now we have to see where the parabola is intersecting the sides of the triangle ABC. First of all, let us see where it is intersecting the straight line AB, that is one of the side of the triangle. It is intersecting at the point 1 by 3 comma 1 by 9. This is one point and another point is minus 1 comma 1. So 1 by 3 and 1 by 9 is clearly the point A. So the parabola is passing through the point A, and the second point is minus 1 comma 1. It is somewhere, let us say here. This point is nothing but minus 1 comma 1. Is this clear? Now the parabola is intersecting the line BC at, it is intersecting the line BC at 1 by 3. I'm sorry, it's intersecting the line BC at 1 comma 1 and minus 3 by 2 comma 1 by 9 by 4, sorry, minus 3 by 2 and 9 by 4. So 1 comma 1 is somewhere here. It's 1 comma 1. This point is 1 comma 1 and another point is minus 3 by 2, 9 by 4, minus 3 by 2. So it's somewhere here, comma 9 by 4, means it is coming somewhere this place. So this is minus 3. It is just a rough diagram. Minus 3 by 2, 9 by 4. Is this clear? So the parabola is passing through these 2 points as well as it is coming down, though it is not looking like a parabola, but let us just say it is a parabola, okay? Now, it is passing through this point. Moreover, it is intersecting AC. If we observe carefully, we will find that it is passing through the point 1 by 3, 1 by 9. That is the vertex of this triangle ABC, as well as half and 1 by 4. So, half and 1 by 4 is somewhere at this place. Okay. So, the parabola is, though my diagram is not exact, that is why we are not getting the exact figure, but it's okay. The parabola will pass something like this, it's passing through this and this. Okay. So we can say in that way, actually, if you draw this triangle properly, you will get the exact figure. But it is understandable that the point that the parabola is passing through this point as well as this point, and this point is nothing but your half comma 1 by 4, and this is 1 comma 1, right? Now we can say that our alpha, that is, alpha is what? It is basically the abscissa of that variable point. Now that abscissa is lying between, that is, alpha is lying between, when we are considering this part, it is greater than minus 3 by 2 and less than minus 1, right? Because that alpha and alpha square is, whenever it is between this region, then we will say that the point is inside the triangle, otherwise it is outside. Is this clear? So we will say that alpha is lying between minus 3 by 2 and minus 1. Now it is also lying between this point and this point. Any point on this is inside the triangle. So we can say that alpha is more than half. We are only considering the abscissa. Alpha is more than half and it is less than, what I will say? It's less than 1, isn't it? It's less than 1 because this point is 1 comma 1. Okay. So in one word, let me just change the color of the pen so you will understand it more clearly. So this alpha, in one word we will write that alpha belongs to open minus 3 by 2 comma minus 1, or it's half comma 1. Is this clear? So that is your final answer. So this way, how we solve the points which is inside the triangle. Okay.